So good morning, everyone, and welcome to this EURECA-PRO talk. It's a series, it's one of the talks in the series of invited talks by colleagues at the partner universities. And today it's my pleasure to welcome once again, for a second time, Tomasz Poloczek from the Silesian University of Technology. Tomasz was here about a year ago. I believe he gave us another more technical talk on his subject, but today we have a different topic, and if I'm not mistaken, we're going to hear about the role of the welding engineer in modern industry, a quite interesting topic, especially for our students. So Tomasz, welcome to Crete once again. Before we get started with your talk, I would like to say that Tomasz Poloczek is an assistant professor in the welding department at the Silesian University of Technology. In 2017, he completed his master's degree in mechanical engineering, specializing in welding technologies, and he got the master title. And then to broaden his expertise, he completed extra courses for international welding engineer, international welding inspector certifications, and he further developed his skills with more and more certificates and testing. And finally, he got his doctoral degree from the Silesian University of Technology, graduating with distinction in 2023. So quite recently. He is the author of 52 publications, and we're looking forward to listen to your talk. The floor is yours.
Thank you.
Make sure you share the screen before you start so that our participants can also view the slides.
Yeah.
All right.
Thank you very much for your invitation. Yeah, and I think that it should work. So once again, hello, my name is Tomasz Poloczek. I'm from the Silesian University of Technology, and we as a Silesian University of Technology and you as a Technician University of Crete, we are cooperating together in the program which is called EURECA-PRO. If you haven't heard about this, I think that you should read about it because it's a really interesting program. So today I would like to show you my presentation about the role of the welding engineer in the modern industry. So first of all you can ask, who is a welding engineer? So in the internet information, you can find the information that welding engineer is a person which have extensive knowledge of physics, engineering, metallurgy, materials, welding, and standards to design, examine, and evaluate welds, as well as to plan, supervise, and document welding operation in accordance with relevant codes, contracts, or drawing. So as we can see here, welding engineers need to have a wide knowledge about a lot of different processes. So you can ask, why do we need welding engineers? Because in the ISO standard 9001, you can find there, it's the standard about quality. You can find there information that welding is considered as a special process, which means that the quality cannot be really verified. So what does it mean? For example, if you have welded sample and you would like to check is it strong enough, for example, you'll need to do the tensile test. But after this test, your specimens is broken, so you don't have them. And you can say, of course, I will take another specimen and I will weld this with the same parameters and I should have the same. But I will take the other. Okay. So maybe your specimens is broken, so you can say that you can do the other one with the same parameters and you are going to have the same. But the process of welding has so many variables that we cannot ensure the second specimen done with the same parameters will be having the same quality. And its successful application requires specialist management, personnel, and procedures. So that's why we are needing the welding engineers. But you can say, okay, but welding process is very simple, yeah? You are taking an electrode and start welding. But we have a lot of different technologies of welding. For example, here on the left side, we can see tungsten inner gas welding, where we are using non-consumable electrode, which is made of tungsten. In the second hand, you are holding the filler material. And you are starting to weld. For example, by this method, you can see that your bicycle frames are made by this method of welding, if you will go outside. So, okay, other technologies of welding. Very popular method, shielded metal arc welding, where you are using the rod, which is covered with special with special materials, that during the welding is making a slag, which is protecting us from oxygen, from air, and things like that. That's the very simple method of welding and very cheap method of welding. So that's why this method of welding is very popular for home use. And the weld, as you can see on the right side, looking not so good and as the tungsten inner gas welding method. One of the most popular in the industry technology of welding, gas metal arc welding, where this method is semi-automated because the wire is automatically given to the welding place. So this method is very efficient and very often used in industry. So first of all, we have a lot of technologies. These are one of the simplest technology, but we have also very, let's say, sophisticated technologies of welding. For example, electron beam welding. Here, this comparison between the method that I showed you before, gas metal arc welding, with the electron beam welding. And as you can see here, if you are welding using the previous method, you need to do a lot of single passes during welding. It's about 100 passes on this joint if you would like to weld 100 millimeter thickness steel. But using the electron beam welding, you can do it in one pass. So you can save much more energy, you can be more ecological friendly, and also economical friendly. Yeah. So the other one of the methods of joining together material, for example, explosive welding, where you are using explosive materials to join together two different materials, which we cannot join together in the normal welding process, where we are heating material to its melting temperature. So we are using impact of this explosive to join together materials. And you can join together materials like copper with aluminum, which isn't possible to do in the normal way. Here you can see the micrograph of this kind of joint. Yeah. So the last method which I would like to show you today, the friction stir welding, where we are using the friction and pressure to take material to its plastic form, to deform plastic material and mix it together and join the material together. So we are not heating material to very high temperature, we are getting material to its plastic form. And for example, we can do the tanks by this method. It's a very expensive method of joining together material, so it will be mostly used in aerospace industry and things like that. So it was about the technology, but we also need to know that we have a lot of different materials that we need to weld. For example, if we have low carbon steels, we know how to weld this, but you can make this steel with the chromium and nickel and have a stainless steel. We have aluminum, which is very commonly mixed with magnesium, and then you have very good alloy, which is used in the aerospace, for example, industry. copper mixed with tin, which is giving us a bronze. Titanium, which is very often mixed with aluminum, and we can get some grades of titanium, or the cobalt, which is mixed with chromium, can give us other alloys like stellite materials and things like that. So what I wanted to show that we have a lot of different materials, and those different materials must be welded by different welding technology. And it's very important to have this knowledge, to welding engineers to have this knowledge. So let's focus on the cars, because cars we have everywhere. Modern cars are built from many different materials. For example, cars have aluminum casting, steel, composites, aluminum sheets, magnesium, aluminum extrusions. Okay, so as we can see, there is a lot of materials, so maybe let's focus only on the steel. For example, here we have a Volvo XC40 and the steels that it's made of. For example, this type of car has a mild steel, high-strength steel, very high-strength steel, extra high-strength steel, ultra high-strength steels. And why do we need so many different steel in the car? Because some part of this car needs to maybe absorb the energy during the impact, so they cannot be too strong. And some of them need to be very strong, that during the impact, they wouldn't plastically deform, like the safety cage in the car. And if of this material will be welded in different method. For example, if we have high-strength steel that we know that maybe this martensitic steel, then we know that we should maybe preheat the material before the welding, because we will be having the cold cracks or things like that. But we also know that if we would weld the ultra-high-strength steels during the impact of this high energy during welding, we can lose these material properties. So the linear energy should be very, very low. So the welding engineer has this knowledge about what can happen to material. For example, if you are having the martensitic steel, you know that if you wouldn't preheat the material, you can have the cold cracks of the level of hydrogen will be too high, the cold cracks. Hot cracking, which is very popular in the stainless steel or in the aluminum alloys. If you will put too much heat, for example, to the material due to the impurities that could be in the material. Porosity, when you wouldn't clean the material before the welding, or the gas flow rate will be too high, and the cooling temperature will be also too high. Or the lack of fusion, where linear energy will be too low and you wouldn't mold the material, or some impurities or not clean surface. So the welding engineer is responsible person for writing welding procedure specification. It's the document in accordance to the ISO 15609, and he needs to write this document. It's instruction for welders how to do the whole joint. In this instruction, welding engineers are writing how to prepare the material before the welding, what should be the bevel angle, how many passes he should do during the welding, what should be the current intensity during welding, arc voltage, travel speed, welding energy, preheat the temperature, is the whole instruction step by step how he should do this joint if he want to have a good quality welds. And it's very important that you have welding engineer with this kind of knowledge. So also welding engineers are using the non-destructive testing to test if those joints are meeting their requirements. So for example, we have penetrant testing. When we are using the penetrant, penetrant is some kind of liquid that's going into these continuities. And after this process of penetrant, you are putting on the surface the developer. It's some kind of chalk, and you can see if on your joints there are any imperfections like that. And also we have ultraviolet version of the penetrant testing, and here you can see the cracks on the ball. Yeah. Or the magnetic particle testings where we are only test ferromagnetic materials, and during the testing we are looking for the disturbance of the magnetic field during magnetic field, and we can say imperfection in the UV light or in the colored observation technique, as we can see here. Also, in our welding world, we have our ultrasonic testing. Here in this method, it's taken from medicine, as all of the, such as a lot of different methods of NDT testings. We are using high-frequency sound waves, and during the testing, if there are any discontinuities in the material, you will have the reflection from the discontinuities, and you will see this on this control panel. Or the radiographic testings, where we are using X-raying the metal material, and we can see what's inside of the weld. If there are any imperfections, like the porosity, like lack of fusion, and things like that. So summarizing this, task of the welding engineer is to define the welding requirements. For example, which material I will be welding, how to prepare the material before the welding, how to prepare the bevel hanger before the welding, selecting the welding method, if I will be using tungsten near gas welding method, friction stir welding method, or other methods. We also have this knowledge which of different types of processes, how they are impacting on the material and its properties. Or developing the welding parameters such as current, like voltage, like traveling speed, like the gas flow rate, and things like that. Some of the material also need the pre-weld or post-weld treatments, due to the fact that some of materials after the welding, the stresses inside this material are very high, and to reduce them, we use the post-weld treatments. Or the quality control and testing, so by which method we should examine our welds. It will be visual testing, magnetic particle testing, or ultrasonic testing. So in our welding world, we have the title of International Welding Engineer. It's the highest qualification issued by the International Institute of Welding. But you can say, of course, but why do I need in my company the person with this title? Because they are required by the standards. For example, if you want to do the building construction, and you have there any welds, if you want to give the sign CE that you are meeting the requirements about the safety and all of this kind of things, you need to have in your welding company engineer with those qualifications, with International Welding Engineers qualification. So it's needed by the law, let's say. So how to become International Welding Engineer? So first of all, you need to graduate of higher educational studies, which are completed with diploma thesis in the field of mechanics, shipbuilding, metallurgy, materials engineering, electrical engineering, civil and water engineering, or chemical engineering. After this, you are going under the EVA training, which lasts about 1 year. And after this 1 year, it takes about 1 week, full 1 week in the month for 1 year. After this 1 year, you are having the exams. The exams last about 3-4 days. And if you pass them, you are getting the International Welding Engineer diploma. So I checked, and in Greece, the examination centers are three of them. One is in Elefsina, it's near to the Athens. One is in Thessaloniki, and one is in Kozani at University of Macedonia. And there are only three places when you can get this title. So if you'd like to become the welding engineer, you will be passing this exam in those institutes. For example, in Poland, we only have one place, and it's located in near to the Silesian University Technology in the same town. Only one place in Poland. So all Polish welding engineers, they need to do the final exam in this only one place. There are no other options. Yeah. So how welding engineers can contribute to SDG 12? First of all, we can use the efficient welding techniques. For example, we don't need to use the welding methods that are giving a lot of heat to the material. We can use, for example, electron beam welding or friction stir welding. We can also minimize the number of defects and rework by using the proper techniques of welding. And if you are following the instruction given by the welding engineers, you shouldn't be having too much defects. Also, you can use the energy-saving welding methods, which is characterized by low emissions. For example, you won't be using submerged metal arc welding. You will be, for example, using laser welding. And we can also try to use sustainable filler materials, the same situation using like electron beam or laser welding. And also remember that welding engineers can design process for repair and refurbishment. For example, if part of your machinery is broken, you do not need to change the whole thing and replace with the new one. You can repair it by the cladding processes. It's also a welding processes where you are putting the layer of the new material, so you can minimize the number of used materials and products. And we can also design sustainable products. So using, for example, materials which will be characterized by high erosion resistance, tribology resistance, or corrosion resistance. For example, for corrosion resistance, it will be nickel alloys. So thank you for your attention. That was all what I wanted to present to you. If you have any question, you can ask now, I think so. That's my email, that's my phone number. And if you'd like to visit our university site, you can go there. Thank you.
Well, thank you, Thomas. Let's thank the speaker.
Thank you.
Thank you for this very interesting presentation. And I guess we have time for questions. So feel free to ask Thomas. I was surprised to hear that there is such an international certificate for welding engineers. And I really wonder, all those people we know in the area doing welding, for everyday tasks, are they certified? Most likely not. I see. Okay. Okay, thanks. And it's a pleasure to have here today a certified welding engineer with us. So he's the best person to talk about this. So any other questions? I do have one more, but you're welcome to.
So my question is, in terms of tasks and duties, do you know what's the difference between welding inspector and welding engineer? Inspector, yeah.
Mostly focused only on the NDT.
Tomasz, we don't hear you. Microphone.
Sorry. So okay, International Welding Inspector is the other title given by this international organization, and inspector is mostly focused on NDT testings, like the penetrant, visual testings, ultrasonic, and this kind of things. And mostly we are using this title. It's written in the standards that you need them in the northern countries like Finland, like in these countries, that you need to have this title. In other countries like Poland, like Greece, like Spain, you can have this title, but you don't need to have them due to the standards, yeah? But welding engineers are mainly concerned about the welding, about how to prepare the joint and things like that. The inspector is about how to test those welds with different techniques. Okay. Because you want to turn off the screen sharing, or?
I turn it off. I just want to maximize the window. Let's ask the remote participants if they have any questions. I was trying to get the Zoom on the screen. If you just maximize the. Okay, and okay, let's get the gallery view. If you can click on OK. And select the gallery view from, no, further back. No. One more, there.
Okay.
The Galleria. Okay. So anybody from our remote participants, I hope you can still hear me because we have some problems with the audio. You're welcome to ask questions to Tomasz. Feel free to turn on your microphone and ask whatever. So in the meantime, I have one more question for you. I was wondering about the welding equipment that can be used for the different types of welding. You mentioned some kind of laser beam technology. So is this widely used? I suppose it gives better results based on what you presented, but is this widely used or is it a new technology?
The laser?
The laser, yeah.
The laser is quite old technology, but now the company, which is called IPG, are trying to introduce the new welding method, but hand-guided method of laser welding, and it's becoming more and more popular. So typical laser welding is the old method of welding, but we have a lot of new different types of using this laser energy to join together material. Yeah, it's now a very nice method of welding, and a lot of companies trying to use this method of welding in their industry.
And the other method you presented with the explosives, if I'm not, is this only for like huge surfaces?
Yeah, we are only doing this for very huge surfaces, and you cannot do this in your laboratory, things like that. It's only done on the military stations and things like that. So you're unable to do this in your laboratory, things like that. And this method, it's not giving a hit to the material, which is very important because you are not changing its structure. You are only use the force given by this explosive materials to join mechanically those materials together.
Okay, I see. So once again, if there is a question by our remote participants, now is the time. Or from anybody in the room? Okay, Professor Gegelakis.
Thank you very much for the very nice presentation. So I'm a chemical engineer. I have almost nothing to do with welding, but I tend to watch shows where people do resto mods on cars, for example, where welding is very much used, right? So the question that I always had is the following. You know how you do a weld and then you sometimes have to test whether what you have done is actually done well or not, right? And by what you presented, I understand that there are methods to test that are destructive and methods that are non-destructive, correct? Right. So I want to reverse the question and ask the following. Does the method of testing the weld in any way affect the choice of the materials? So vice versa, right? You have certain materials, you have to weld them together, then you do the testing. And the question that I'm asking is, if the testing that you will have to perform for any quality assurance will affect the choice of the materials beforehand.
Yeah. So that's how we are doing the welding process. Phil, you need to have the welding procedure specification. It's the document where you are testing the whole specimen by destructive, non-destructive testings. And you are checking if it's meeting the requirements. If your weld, it's not meeting the welding requirements, you need to think about this. That might be something wrong in this process. Maybe the technology was wrong. Maybe I'm using not the proper material for welding and things like that. And after, when you have qualified this technology, you are starting doing the welds. Yeah. Okay. And you are testing them only by non-destructive testing. After that, you know that it's good enough.
Thank you. Thank you very much.
Please.
Thanks.
Okay. Well, if there are no more questions, let's thank our speaker once again. So thank you, Thomas. And so we have some refreshments and quickies. For those in the room, for our remote participants, you just imagine you're here because we cannot do more through Zoom. Okay, thank you. Thank you, Thomas.
Thank you for inviting me here to Crete. It's a pleasure.
Pleasure for us. Okay, and we will have more time throughout the week. Thomas will be here until the end of the week, so feel free to talk to him and arrange possibly a lab tour or like a one-to-one discussion on research topics. Okay, so thank you, everybody.